So let's quote Gartner here. So Gartner made a prediction, as they do. They make many predictions. And in 2018, they predicted that by 2018, we'd be seeing digital event notifications forming 60% of new digital solutions, that over 50% of business organizations would be participating in some sort of event-driven system, and that 50% of organizations would be, with their APIs, managing some kind of event mediation going on within their operations. Now, however good Gartner is at making predictions, and I think some of you may be spotting what's coming next, I don't think they were predicting this. And the pandemic was an extraordinarily hard time for many of us, and the last 2 years have been super tough. But the one thing it did do was press the accelerator pedal right down to the ground when it came to event-driven architectures and pushing them forward. And it was a tough 2 years, but this, without doubt, is one of my top 10 memes, because I think it accurately described what happened. And I certainly know in the UK, as an example, where we had these supermarket services where you can book your groceries online and then the major supermarkets come and deliver them. It was doing all right prior to 2020. That business model went through the roof. They could not hire drivers quick enough. They couldn't hire developers quick enough. All of that being sort of driven by this appetite for event-driven architectures. So what's behind the trend? This is not a completely exclusive list of all the different things that are happening, but these are some of the big ones. So growth in microservices. So this idea of thinking about having one service per API, just splitting these things out, having dedicated services, and that's helping to remove the dependencies. Maybe your services don't all live on the same machine, so you need to start thinking about the asynchronous connection of being able to talk to them. And as soon as we start moving into asynchronous connections, we're starting to think about event-driven architectures. Real-time decision-making or just-in-time decision-making. So this is absolutely huge when you start to think about opportunities you might have. So you may have some kind of a model that you've built on historical data, but with events, you can start to develop that model. You can start thinking about adapting it. So for example, if you're working in financial transactions, every millisecond counts. And if you get a event change and a state change, you can go away, take that and do something with it. And the big one is decoupling concerns. So some of this feeds into the microservices piece, but maybe you don't want to go down to that level. Maybe you're looking to break down the monolith, which is the popular thing. And if you've got a couple of systems, if system A tightly coupled with system B, the challenge you have is if you change system A, what's going to happen to system B? You now have to do changes. And just by being able to break those systems apart and having some kind of intermediary in the middle, that problem goes away. So if system A changes, system B doesn't need to know about it. So what's the big deal? So I know we've talked a bit about, what it looks like, but what's the big deal? And for me personally, where I get really excited is what happens when you start to bring lots of different things together. So for example, if you've got an event, so that's effectively going to be a state change, something changed, we send an event about that state changing. You've got your domain data, so this could be a big bucket of data, a database somewhere containing information around your domain. So I'm going to pick a traffic scenario here. So let's say our events are going to be telemetry data from a vehicle where we're getting information about its current location, its speed it's traveling at. Our domain data could be route information. So we've got information about what the roads are, what the speed limits on those roads are. Do we have any junctions, roundabouts, anything that we've got static information. And then the third bit is knowledge. So having that domain knowledge about how you can apply information such as a vehicle location, its current speed, combining that with a map, so it's on a certain road and that certain road has speed restrictions and maybe it's got a junction coming along, and then domain knowledge, which says, hey, you can put these things together, we can put a model, and we can now predict where a vehicle's going to be. And that gives us an overview of the bigger picture. So we know where a vehicle is at a given time in a road, and we can start to do things like make predictions. So as an example, we can pull all these things together, and if we've got a car on a certain road, we can say, hey, we can predict reasonably accurately that in 10 minutes, it's going to be at this location. Now, if we bring in even more data, so let's say, for example, we've got some weather data, we can now start to go, well, okay, it's going to start raining shortly, and we know that when it starts to rain, traffic tends to slow down. We've got some more information about traffic, either because we've got that telemetry data from the other vehicles in there, like a bit like Google Maps does, or maybe we're using the more traditional approach where we've got traffic cameras. So we know that in 10 minutes time, an area which was already fairly congested is going to become significantly more congested because of all of these things coming together. And we can now make a just-in-time decision. So we can say, okay, so we know in about 10 minutes' time, it's going to get really messy. And actually, this person's driving on a motorway. So we know the junctions that you can turn off of that motorway are few and far between. So we can now make a just-in-time decision to suggest that you change route. We're going to reroute you so that you can avoid that congestion and move on to this other road, which is not so busy. And this is cool because we can start bringing all of these components together and we can start to think about how we can monetize this. We can create new data products, we can create new data services, we can sell them if we wish, or we can use them as value adders to different parts of our system. So for example, with Google Maps, where you've got a dynamic route mapping, and it will pop up and go, oh, we've detected some traffic, switch over. If this was a logistics company, maybe we could sell a product such as being able to give you a more granular delivery time. So if you've ordered something as a customer, maybe you pay a premium service and you're going to get live updates if your delivery is going to be 5 minutes later, 10 minutes later, that kind of thing. Whereas, the bog standard cheap service would be, well, we'll give you an 8-hour slot and, just be indoors then. So you start to get a flavour in this. And another one, which is going to nicely lead into the examples we're looking at today, is if you've got some kind of a taxi request service and you go, okay, we've got weather data, we're in the city, we've got weather data, we know that there's already quite a few people booking our taxis, it's going to start raining in 10 minutes and it's going to be a heavy rain. Let's put in some surge charging so that we can attract more drivers to come online, to be available for the drivers, and that this is the product value. So we're incentivizing them to come online so that we've got more taxis available for people to request them because they don't want to get damp as they're walking home. Okay, so we've talked about the rising trends. So let's do a quick reminder of what event-driven architectures are. So let's pick a very simple example. We're going to keep sticking to this story of this taxi service. So we've got Mario here, and he would like to book a taxi. So he will send a request to the taxi service. They're going to receive that request. They're going to acknowledge that request, so they'll send some kind of response. And then they're going to allocate a driver for that request, and the taxi comes on its way. Now, if we look at what this might have looked like prior to event-driven architectures, Mario would have sent some kind of request. Maybe it's going to be something RESTful. So you're going to post a request for a booking. We're going to get acknowledgement from the taxi company, and they're going to go, yep, that's great. Here are here's your booking ID. So you've got a booking ID for the accepted request for your taxi. But it doesn't stop there, because we've acknowledged the booking, but we still need to find the driver. And you think about, well, how are we going to do this in say, for example, for a RESTful state? We're going to be doing a lot of polling. So we're probably going to go either manually, probably not, but the client's going to keep sending this recurring request going, okay, can I have an update for my booking 123? There isn't one yet. We haven't found a driver. So maybe we send a 404 or some kind of equivalent response message. Nope. I haven't got one yet. So you wait a little while and you go, all right, is my taxi ready yet? Is it here yet? Unfortunately not. Okay, so we wait a little bit longer. Wait again. Do I have a taxi yet? Yep, we've got a taxi. We're all good. It's on your way. And the challenge with this is we get this sort of polling madness going on. So it's a waste of resources. So if you think about what's happening in this situation, so for example, we have got sort of like some sort of a mobile app or a web app. And because we're going to be passing on our details, we're going to want to set up some kind of connection, which we'd be doing normally, but we're going to have a secure connection. We need to do the authorization. We need to prove who we are. And that can be expensive. So if you're roaming and you've got limited bandwidth, or it's going to be quite expensive, each time you're sending these polling requests, it's not a great use of resources. It's not really real time either, because we're having to keep sending this polling. And in certain situations, that's fine. We don't mind waiting a few seconds. But if we think about sort of automated financial transactions, that kind of thing, every millisecond counts. Every millisecond, you're not either putting a trade in or closing a trade. You're potentially losing millions. And I think the real big one here is, if we're thinking about monetizing APIs and using them as products and as services, it's really difficult to enforce quality of service policies. So, for example, I'm going to use Google Maps example as well. You can get the API, they've got different sold products. And if you're using that in some sort of a real-time setup, it becomes really difficult, because if there isn't a change of state, but somebody has to keep polling that API to find out if there's a change of state, you're effectively, in this situation, well, do you charge them, but you've not given them any information? How does that work? And then all that pain that's associated with that. So how do we solve this problem? Event-driven architectures, they come to the rescue. And what we've got is a publisher, and we've got some consumers. And effectively what's going on here is a publisher sends a message, and a publisher doesn't really need to worry about who's consuming that message. They just want to send that message and then move on to the next task and send another state update if it happens. You've got the consumers, and effectively the consumers will say, I want to get that message from that publisher, so they're going to create a subscription. And you've got the message broker in the middle that's effectively facilitating that communication. So what will happen is, if a consumer wants to get updates from a particular publisher, they will create that subscription request. They will then receive messages as and when they come along, so the broker will pass them along. The publisher doesn't need to know whether there's no consumers or 100 consumers, and it's a great way of just splitting things apart. So if you make some changes to the number of consumers that you have, publisher is like, yep, fine, whatever, keep going. So coming back to our taxi example, if we think about what this is going to look like with the message broker in place, when Mario is looking for a taxi, he'll have a subscription to the broker. He'll publish that request to the broker saying that he would like to get a taxi. The taxi service has a listener going on, so they've got a subscription to the broker. They consume that message that's been received. They will then send back an acknowledgement. They will say that a taxi is booked. That will go for the message broker. That is received by the mobile app. And there you go. Mario knows he's got a taxi coming and he's got a driver allocated. But it's not so simple as that. If we come back to our example before that we spoke about, the big question mark is, what does this bit look like? And this is going to be true as well of what happens with the other systems. So if we're assuming that the taxi drivers working for this company have also got mobile apps, this is all going to be true of all of that. We're just going to focus on this bit here with the customer looking to book a taxi. And this is where it starts to get a little bit messy. So me as a developer who's going to be building this mobile app, do I really want to be dealing with the direct communication with the message broker? Do I really want to be worrying about the security? How am I going to handle the interaction with how the web app's going to connect to the broker? I mean, from the broker's perspective, like let's say this becomes a really popular taxi service. Do we really want millions of different mobile apps sort of having this direct connection to the broker? It gets really messy, and there's that question of, should that even be happening? So what can we do about that? And I'm going to bring back polling, because actually sometimes it's a perfectly valid use case. So let's say it's not going to rain. Mario decides, you know what, I'm not going to get a taxi, I'm going to get the bus. So he goes to the bus stop. In this situation, it's perfectly fine to go off and do something like a RESTful request where you've got the bus ID, The bus is continuously streaming data, so we've still got events going on. The bus is going to be streaming events as to its current location. Maybe it's streaming the speed. Maybe we've got some data elsewhere telling about what stops it needs to visit. But it's perfectly fine to go off and send a RESTful request saying, "Here's the bus ID. Give me some bus times," and maybe Mario goes off, does the initial thing. This is anonymous. We don't need to do anything special here. Get some information about what buses are coming. Mario is quite an impatient person, so he waits a couple of minutes and he goes off and sends that request again, gets the latest update of where the buses are coming. A bit of drama, by the way, because the 248 has just overtaken the 211. Exciting times we lead in London, what can I say? And then he waits a couple other minutes because he's really impatient, does another refresh, and there we go. So we've got the latest information. It looks like Mario's going to be catching the 24, which is due in a minute. So that's totally fine. And we want this kind of model where, for example, we just want to, that there is no need to further question things, further ask questions in the back-end systems, or maybe internet connectivity isn't great. Maybe we're not too worried about setting up some kind of authentication. So it is valid. So how are we going to avoid API proliferation? So we've talked about this rising trend of event-driven APIs. So that means we're going to have a lot of APIs. And it's not even the event-driven aspect. Just in general, there's this big push towards API as a product, API as a service, API first. So we're going to have lots of APIs. So how are we going to go about managing them, understanding where they are, discovering where they are, finding the documentation, being able to help developers improve that development experience? How can they find where the APIs are? How do we enforce governance? So as we produce more and more APIs, how are we going to make sure that we're following any governance rules that are provided, that we are sticking to naming conventions if we have them, that we're reusing things? If a service already exists, don't go rebuild it, go reuse it, and so forth. Secure access, this is a big one. How are we going to make sure that we're securing access to our APIs through authorization and authentication, but also from the perspective of protecting our back-end systems? So things like not having 10,000 calls per second from one client and that kind of thing. Unless it's a valid use case to have 10,000 calls per second from one client. I'm struggling to think of one, but there might be one. Monitoring who's accessing what. So, for example, how are we going to be able to understand what APIs are being accessed, when they're being accessed, by whom, and also looking for uncharacteristic behaviors? So is there something unusual going on, and do we need to act? And more importantly, what happens if a backend system goes down? How do we monitor that an API is no longer available so that we can put some alerting in place to do something about it? And last but not least, minimizing that impact of change. How are we going to do that when we update APIs, when we decide, hey, you know what, we don't like Kafka anymore, let's rip that out and put a RabbitMQ in instead, and that kind of thing. How do we look at all of that? So let's do our introduction to API management. So API management is the process of creating and publishing APIs. So there's no point of going to this effort of building APIs if they're not discoverable in some way. And what API management helps us do is basically gives you a mechanism to be able to create them across their life cycle, publish them, make them discoverable. API management will also help you to enforce usage policies and access control. And if we think about from an API alone perspective, and if we think about, we were thinking of how we're going to do the access control, how are we going to do any policies, we're kind of doing that on an API by API basis. But what API management allows us to do is to take a step backwards and go, well, actually, we've probably got a whole bunch of APIs that the same types of user groups are going to be using. And for that same user group, that's what we're going to have the same security policies, we're going to have the same usage policies, we're going to have the same performance policies. And you can do that on a big scale rather than on an API basis. And also, again, controlling the access. So do you want to issue API keys for the APIs to be used? Do we want to use things like identity providers such as Google or GitHub and so forth? API management also helps you nurture your subscriber community. So your developers who are using your APIs are your customers. You are the customer when you are using third-party APIs. And API management helps you manage that developer experience. It helps you help your developers to understand what's available, as well as how they can subscribe and use your APIs and consume them. And last but not least, what can't be measured can't be monitored. So API management will also allow you to see how your APIs are being used, how they're being consumed, who's using them, when are they using them, are there trends at certain times of the day that are being used, is there unusual behavior, has something gone down and do we need to deal with it? And if we think about the anatomy of an API and the various things that we're worrying about, what we're saying is, use API management to deal with all of these components. And then what you can do here is you can take that step back and go, well, like, I've got a load of APIs that are like our customers use. So these are the policies, these are the logins, these are the things that we apply to that group. We've got a load of APIs that we use internally. So here's a different set of policies and monitoring. We've got our governance processes. So this is, we sit there from a company perspective. This is what they look like. Let's apply them. Same with design. This is how we can improve the user experience through some kind of a portal to advertise them. And the key thing here, you focus on the core business logic of what your API is supposed to do, and everything else, let API management deal with that. Okay, so we've talked about the rise and trends of APIs. We've talked about what event-driven architectures are, and we've had an introduction to API management. So what we're going to do now is bring it all together and have a look at some scenarios, which you'll be surprised to hear about, continues our taxi story. So let's start off with an example API management platform. I'm going to go over some of the key components of Gravity's one, which is an open source platform. There are other API management platforms too, and they're all going to do these things in a similar way. So I'm just picking this as an example so you can start to see how the things come together. So we've got a number of actors here. So our first actor is our app developer, the person who's in charge of building that mobile app for our taxi service. And the kinds of things that they're going to be interested in is just discovering what's available. What APIs are there? What's the documentation on there? Maybe they can read feedback that other people have left. Maybe they're going to leave their own feedback. Maybe they're going to want to try out that API, so we can put some kind of a sandbox or something behind it so they can test it out and see what happens. And eventually, they're going to want to subscribe to that API. And there's going to be different ways depending on how it's been implemented. Maybe we use API keys. Maybe we're going to use identity providers. We can go in and start to think about what access management process we want in there. So the developer goes over to the developer portal, they have a look, they find what API they're interested in, they read the documentation, great. So the next part is handling the actual creation of the API, the whole API lifecycle part. And this is going to be handled either by the API owner, who's going to do the manual stuff. And when we've figured out exactly what this is going to look like, so if we say, okay, these types of APIs, we're going to apply these certain policies, these procedures, we can then automate that. We can build out a pipeline and use something like CI/CD processes to go away and manage that for us. So in this scenario here, we've got the API management console. So this is where you're going to go, and if you're using things like design first principles when building your API, you can import in your API definition file. You can use that to generate your documentation, generate any mocks that you're going to be using, or any code stubs that you want to publish as part of your proxied API. You do your management piece here. You put on any kind of policies that you need. When you're ready to, you can deploy the API, which we'll do onto the gateway, which we'll look at shortly. You do your monitoring and your analytics. And again, when you're happy with that process and you know it's for groups, you can go away and automate that and set that up as part of your pipeline. So every time you've got a new API that you'd like to publish, you've effectively got that process up and running, and then you don't worry about the security and the monitoring and the logging and all of that stuff. And last but not least, we've got our API gateway, which acts as a reverse proxy for our APIs. And our fourth actor is our mobile app. So the mobile app is going to be invoking APIs, so the proxied APIs on the gateway. And the gateway isn't just a pass-through, although you could use it as a pass-through to your actual APIs to your backend systems. but effectively it is the gatekeeper to your APIs. And this is when you're happy with your APIs and you've done all the development pieces, you are now going to be publishing them onto the API gateway. And the API gateway is going to be enforcing all of your policies that you've decided. So your security policies, your performance policies, any kind of rerouting and that kind of thing. And something to mention as well, so not all API gateways you do have to check, but what they can offer as well, which is really neat, is you can also do protocol mediation. So we talked about a mobile app talking to a broker. Slight challenge we're going to have here is that your mobile app is probably using HTTP, HTTPS, whereas your broker's probably using TCP. And what an API gateway can do is mediate the protocol. So effectively, if we do decide to change things, mobile app doesn't need to know about it. And if we're changing something on the mobile app, broker doesn't need to know about it, or people who are managing that. And we can also do data transformation and all of that good stuff. So one thing I quickly want to flag here whilst we're on this slide is API management is not equal to API gateway. So API gateway is where we're publishing the proxied, our reverse proxy for our APIs, and we've got the policies in place. The API management piece are the two bits above. So those are the things that are helping us take that, that high up view of what the things need to look like for APIs, what are the policies driven by whatever the business policies are, or security policies and so forth. That's the piece that's giving us the API management piece. And then the API gateway is just part of that piece that manages that life cycle of when the API is up and running and what policies are being applied. So if we go back to our taxi example, what does this look like now? We've got our app developer who's building that mobile app. So they've gone to the developer portal, they've found the request taxi API, they've read the documentation, all great, they're doing their work. Obviously, you've got the API owner who's already deployed this API, they've done that stuff, and they're just doing the management, monitoring, and analytics piece. They're keeping an eye on that. And that's been published onto the API gateway. And we've got the mobile app, and they're now able to send their request to book a new taxi. That goes into the API gateway. Here, we're doing a number of things. So we're applying our policies. So if we need to do the user login, we're handling that. We're doing the protocol mediation and so forth. We're also monitoring the health of that API. So if something happens to the backend systems, we can have some kind of alert to deal with it. We can tell the user accordingly and so forth. And that request that's sent from the mobile app is transformed, put onto the message broker, and is going to the rest of the taxi booking company. So if we start to break this down a little bit and look at the examples of what's going on. So let's say we're now booking a taxi. So we go off, we send our request, we need a taxi. And we send, it's going to be like an HTTPS request. And what we can do now is we can set up a WebSocket. So this is how we're going to do the streaming on the mobile side, so that we can open up a connection, get some information about our booking, and then sort of carry on. So we do that. The API gateway is going to go away. We're going to check, yep, get you logged in. Are you logged in accordingly? Have we, do we need to now transform this HTTPS to TCP to be able to put into message broker? And we're probably going to be doing some data transformation as well, because what we're sending in the request might not be the right layout that we need to be able to put onto a topic. So we can do that transformation too. So that goes to the message broker. That then goes onto the service. They will confirm that they've received the booking. They'll also confirm that they've located a taxi and the driver. That's being sent back to the app. And you can see what's happening with these flows, that the data is being transformed. The protocols are being mediated between the mobile app and the broker. And unfortunately, Mario's being awkward and he's decided to cancel the trip. So, okay, we've got another request going in. We can start closing off the whatever subscriptions we had with the broker and move on. A next example, so still sticking to the streaming idea, is where's the taxi? So the previous example, we looked at bidirectional data, but we can still do the same setup where actually what we want to know is the location of the taxi. We don't need to do any kind of interaction. We just want to open up a connection, find out what's happening with our taxis, and send them on. Okay, so again, this is likely to be another HTTPS. So we're going to set up set up something like maybe event sourcing. That gets transformed into TCP. We're getting that location information of the taxi that's continuously being streamed. And then either there's going to be a timeout of when we're going to stop sending the taxi location, or maybe we'll call the connection when the taxi has arrived, and so forth. Last but not least, let's bring back our bus. Bring back the bus example. So we've got a number of things going on in here. So we've got the bus and we've got the telemetry data. So we know that data is continuously being streamed. So we know the bus location and the bus speed at any given time. And that's being streamed to the message broker into some topic or channel somewhere. We also have a route database. So this is more or less static data. In this database, we've got the bus number, we've got all of the bus stops that bus stops at, and maybe we've got some historical data about, on average, how long does it take the bus to go between these different stops. And we want to know where's the next bus. So we send our RESTful request to the gateway. Now, this is an interesting one here because we don't need to have people signing in to find out when the next bus is. And also, if this is the Westminster Abbey bus stop in London, you've probably got loads of people at that bus stop, and all of them are probably going, right, when's the next bus? So we can introduce caching, because that data is probably going to be fine for a minute. That data is going to be fine for a minute before it becomes stale. So even before even before we even bother going to the back-end systems, the API gateway can go, oh, somebody already requested this about 5 seconds ago. I'm just going to send you what I've got in the cache. And then when the cache is stale, then we can go, well, okay, we can go to back-end systems. But just by going to the cache alone, that's it. We don't even touch any back-end systems, and we've served the purpose of what we need to do. But if the cache is stale, okay, we go to the gateway. And what we can do now is some dynamic routing, because we want to pull data from 2 places. So we want to pull some data from the route database. So for the bus stop ID, what are the buses that serve that bus stop? And we can also send a request to the message broker. And all we're interested in here is just the last message that we received for the buses, the relevant buses and their current location. And then we can do some magical data mashups going on here. We can do some data data transformation, and we can send back that information about when the next bus is. And the thing is here, this is fine. Whilst we're using streaming data, we're not interested in getting an event update. All we're interested in getting is just tell me the last thing that you had, and then we're going to apply some business rules to give you that data. Probably worth mentioning, if you are planning to build a taxi app or a bus stop information app, probably not going to use this to the letter. These are all just examples of the various things working in play. Okay, so have we achieved great happiness? So I'm going to leave you with some concluding remarks. So we're seeing this rise of event-driven architectures, and they can cause a number of challenges for us to face. So API proliferation, having all of these APIs, how do we know where they are, their documentation, what do they do? Implementation complexity, so how are we going to, especially as we get more and more APIs, more and more systems wanting to talk to each other via brokers, how do we manage that implementation complexity? And those challenges around security, both performance-wise and whether people have got right access to things, the governance side of it, are we making sure we're following our standards and reusing stuff and that good stuff, and just monitoring, just understanding how things are being used or not being used, and any problems that may arise. API management can help us by providing that end-to-end API lifecycle management piece. So effectively, using that, we can just focus on the core business logic of the API, and then all of the other stuff around that, we can defer to API management and look after that. And that helps simplify development efforts, which means overall we improve developer experience through just cutting down how much work you have to do or having to rework or re-architect things. Thank you very much. So if you are interested, you want to have a go, do have a look. Again, there are many API management platforms. You can check this one out as well. If you do have any questions in general outside of this conference, you've got my email details there. You've got my Twitter address. My DMs are open. You can also find me on the forum and drop me a message. And we've got our repo there as well, so if you want to go and have a play, please do. So thank you very much, and I hope you have a wonderful rest of conference. Hey, ciao. Hello, hello. Sorry?
You need a recommendation?